Sure, I'm going to mute myself.
Live streaming is on.
Hello, everybody. Welcome to the Linux Users Group of South Carolina. This is Upstate South Carolina Group, Columbia Linux Users Group. We are glad tonight to have George Law showing us some amazing image stacking, and then Barry Jones, did I say it right, Jones? Going to be showing us Terraform and Ansible, the PB&J of DevOps. Without further ado, I guess, George, take it away.
All right. So I'll start on this page that I put together. I had kind of gotten, seeing a friend of mine from IBM posting all kinds of waterfall pictures like this one on the screen kind of made me, I questioned him as far as how he did it. And he's basically setting his camera up to do Lightroom. And I kind of figured, well, there's got to be an easier way to do it without paying Adobe and without having a $5,000 camera. So what I started with is to kind of, this is a video I shot here of East Etoe Falls up in Sunset, South Carolina. And I figured that there had to be a way to take that, and knowing that the video was basically just 30 pictures per second processing as a video file, I figured I could cut it up with one tool or another. And then I started this with a GIMP plugin, which I have since lost, but I came up with a way that just the default ImageMagick tools that come as part of most Linux distributions as an optional package can do much of the same thing. So what I did was put it all, I started out doing a lot of manual processing and figured, well, I'll put it in a script, and then the script kind of evolved to from something where all the parameters were in specific order on the command line. I kind of turned it around a little bit to make it more flexible so that you could do, for instance, here you can do like -F and give the video file -F to give the filter, which is basically the transformation magic that happens, and then some other flags that I introduced. So just to, I'll run through the script real quick. And it's pretty basic. It's just bash, nothing even function or procedural based. It's just pretty straightforward. And like I said, options -F is you give it the video file you want to parse through. F is the filter that I'll explain later on how to manipulate the image. What it does is it'll look at the video. Most high def video is 30 frames a second. HD, you get more. I think HD is 60 frames, or that might be Ultra HD. But what it'll do is it'll look at the video, determine the frames per second, and then it will tell FFmpeg to take that many, and grab that many images per second of video. And what you can do is you can also pass an -R. So if the video frames per second was 30, you can pass -R 15, and what it's basically divide your frames per second by -R, so you can reduce that down. If you said -2 for -R2, it would do 15 frames. -R 15 would do 2 frames. And that's kind of, I found that sometimes more frames per second is not always a good thing, because sometimes it can introduce more noise into the video, the pictures. And then you can say things like -S and give it, say like 1:30 to tell it that you want to start capturing the slides from the video at 1 minute 30 seconds. You can do -S1 to have it do some in-script video stabilization through a Perl, Python 3 library. And then there are -D. You can also say only capture 10 seconds of the video. So then the script is basically just going through, it checks to make sure, hey, do I got FFmpeg and ffprobe and convert. FFmpeg is sometimes its own package. Other times it's part of, I think it's AV convert. Then convert is part of ImageMagick, IMAGE, and then Magic, MAGICK. Runs through and grabs all of the, for -F, if it sees the first parameter is -F, it will grab the file name from the second parameter and then do a shift, which bumps the parameters, basically bumps -F and the file name off the list of parameters. And then it does the rest of the parameters using the same method. Then just some basic error checking. Then we get into the main logic, where if you say you want to stabilize the video, it will run the Python video stab library, and it's pretty basic. I don't really, there are some options to it, but I just run it with the basic options. If you don't indicate you want to stabilize, it just takes the same new video file and makes a copy of the input. So it never changes the input video. Then it looks at if you pass it the start time and the duration, and then just to make sure that it gets the video settings, it calculates later on, it runs it through FFmpeg. Basically, it just says start at start time for so many seconds, and then it saves it to that same new vid file. And from there, it just does the calculations. So it'll, ffprobe just gives a list of parameters on what the video output has. So it'll say things like, it'll give the duration, the bit rate, the stream, will tell you what type of video encoding it was. Really what I look for here is the duration and the frames per second. So it pulls those out of that temp file with some regular expressions. And then if you're doing the reduce factor, it'll then convert that down to images per second to pass on to FFmpeg. FFmpeg just basic for NuVid. Dash Q1 is basically just the quality of the images. It doesn't, basically it's 1-to-1. The dash R option here, the placement in the command line is important. If you were to put dash R, for instance, before dash I, then it tells FFmpeg to use that option towards the input, not towards the output. So basically this just says to FFmpeg, take the input file at a rate of 30 frames per second, or whatever the video is encoded at, and to output that as into temp directory with the file names will be slice underscore, and then it will auto number the files. So the first one will be 0000, second one will be 0001, etc. Once it's got all the images, then it does the image magic convert to basically take the filter that you pass it, and it'll run all the slice images through the filter and produce an image called stored in new name here, which is just made up of the original image name or video name, stacked, what the filter was used, and then a PID, just so I can run this multiple times and compare different outputs without always overwriting the original the ending image. So any questions as far as the script itself, and then I'll give some example videos that I used and output and things like that. And thanks, Jace, for your input. I kind of reformatted some things if you didn't notice. So going back to this waterfall video, I ran it through just a straight, no extra options. So I told it to process my Twin Falls video with the median as the filter, which captured about 455 images, and then it ran those through convert And if you watch the video, for example, the flowing water, it's got a little bit of lens flare here up in the right corner that you can see in the final image. But that's you can see how it's kind of got the flowing output compared to a single snapshot of a waterfall that you might have taken on your camera or phone. Some other examples.
Hey, George, could you focus on the lens flare? I'm curious to see what that. I'm sorry. Zoom into the lens flare, the rainbow part.
What's that?
I was just wondering if you could zoom into the lens flare rainbow part. I'm curious what that looks like.
You can see it here in the upper right corner of the finalized image. I tried some different freeware-based video editing just to see if I could reduce that down, and I didn't really have any luck, and kind of ran out of time with preparation. Just to give an idea of some of the other videos I used here. This was one I found off the internet. So it's actually several clips. And this kind of illustrates the whole start time and end time options. So with this, what I just did was, the name of the video was Night 1099. I passed it -D to only capture the first 6 seconds of video. And then the median filter, which basically just kind of averages all of the pixels in the image. So in the case of a waterfall, you get a smoother image of the flowing water. In the case of like the nighttime sky video, you don't really get much for median, but with the this is the max filter, which gives you it's basically records all of the pixels as they move throughout the picture. Oh, hang on here, wrong key. And then this was a second video of a nighttime sky. Just the Milky Way as it moves across the nighttime sky. And then the same type of, with median, you just get the average of the pixels, which really isn't real impressive. But when you do the max, you get the blend of all the pixels as they move throughout the picture. So you get the top and across the water on the bottom. Let me see here. Then I kind of tried to I did another waterfall video I shot of Oconee Station Falls. That this image, I did the same actual process through 2 different Android apps. So I found an Android app that would let you do the same type of slice images, 30 frames per second, and then do the stacking right on my phone. I spent probably 4 hours trying to parse this video through my script to make a similar image. And I think like I mentioned before, if you take too many frames per second of the image slices, it tends to introduce too much noise into the image. So I couldn't really duplicate this output with my script. Basically just because I, again, ran out of time. And then just some other notes. I ran this script. I've got a couple systems here. I've got one that's old first generation dual core system with 8 gigs of RAM. And doing it got about halfway through processing the images, and then it just started to kill things in the background. Tested it on this machine that I'm sharing it from, which is a newer model AMD CPU with 16 gigs of memory, and watching top in the background, you could see where it went to about 9 gigs of memory used. So with the processing I had tried before with GIMP was also hitting a memory issue. I'm not sure if running it on this beefier machine with more memory would have helped or not, but I've been playing with this in the background. I'm kind of got this week off from one job, and I start a new job on Monday, so I'm kind of been free from some of the stress from work, which has really given me some enjoyment tweaking on this script just to try some different things. And then as far as the video stabilization, what you can do, this is a screenshot right from Google Photos of the video I shot at Oconee Station Falls. And on your phone, if you go in to edit a video, the little icon that I circled there actually Google will do stabilization. So if you're shooting it handheld without a tripod or anything, it does a pretty good job to take any shakiness out of the video. It's not perfect, but it helps. This was like a 22-second video. I've tried taking like the first 10 seconds, the second 10, taking only 15 slices per second, but I still cannot really produce that same image that I made on my phone with my script. I think that's quick and dirty. That's pretty much all of what I've got here. I was going to try to do, this was the big eclipse that we had here in South Carolina a couple years ago. A friend of a friend shot this time lapse in Oregon. I might try to do something similar with this, but I don't know how it would come out. Just to give a quick idea here.
Now, George, you put a link to your GitHub for the script in the notes, right?
Yes.
Okay, fantastic. I can't use it if that's all right. That's really cool, George.
So let me, I was just gonna, well, I kind of lost the screen share here. So in the page, there's an option for the convert options that'll give you, there's literally 30 different values you can give it in. You just do convert dash or hyphen list and evaluate, and it's literally like 30 different functions that ImageMagick can apply to images. The median works best with the daytime images, the waterfalls, where you want to get an overall average of all of the pixels. And then max is the one that you would use, for instance, for the nighttime stuff, where you try to get the stars tracking across the sky and plot those all together as that movement happens. So I will follow up with an email after the meeting with some more notes I've got, and then we can discuss on the Epilogue list if there's any other questions.
Well, thanks a lot, George. That's really kind of cool. That's really cool. I appreciate you showing off for us and giving us a demo and the results you got. Were really kind of neat. Thank you.
All right. Thanks, everyone. And I guess Barry's up.
Yeah. So our next presentation is Barry. Thanks for coming tonight. We really appreciate you showing off for us. I'll let you take over. Thanks a lot.
All right. Well, thank you for having me. I hope everybody can hear me all right. You'll see a little link at the top right there. I'm using the Google presentation. And if y'all hop on there, if anybody has a question, it'll kind of propagate on my little speaker view. And you can upvote other people's questions and whatnot, and I can answer them through that at the appropriate time, rather than people having to chime in on the audio. So just wanted to mention that. But anyway, thanks for having me out. I'm going to be talking about Ansible and Terraform, the PB&J of DevOps. And I've been using Ansible for a few years now, and I've been learning Terraform over the past month or so. And if you start looking around on the internet, you will find multiple examples of people putting these two tools together for DevOps automation. They work really well together. They both are very good at the individual area of focus that they have. And one of the biggest things to learn when you want to start using them together is how to get them to talk to each other effectively. And there's a lot of ways to do it. And so I'm going to cover each one at a high level through this presentation. I'm not going to get too far into the weeds on either one of them. So just know that in advance. But I will try to go through this assuming that in general, y'all don't know anything about what we're going to talk about. So we're going to try to cover everything and make sure we cover any weird acronyms or anything like that so that you know where we are. So let's start at the beginning. First off, what is a PB&J? PB&J, this is from Wikipedia, is a peanut butter and jelly sandwich. Consists of peanut butter, fruit preserves, spread on bread, often white. Usually kids like that a little bit better. You can cut it open face if you like. It's very popular in the US. Apparently, the average American will eat 1,500 of these before graduating high school. Lots of variations, use bananas, whatever you like. But it's very popular. And so this is a very popular combination. So for purposes of this presentation, a PB&J is a common and well-accepted combination of ingredients. How does this relate to DevOps? Well, glad you asked. DevOps is, of course, a loaded and very broad term. I mean, with DevOps, you can be talking automation from standpoints of testing, of combining two normally separate groups and giving developers more power over the infrastructure. You can talk about coding and automating your infrastructure that way. And there's entire workflows and study groups and certifications and everything that go into DevOps these days. Specifically, when we're talking about Ansible and Terraform, we're talking about infrastructure as code. Because infrastructure needs to be both provisioned and configured. Provisioned, you need to say, I need this many machines, I need them to be on this VPC in my cloud provider, I need these DNS entries created, and as far as being configured, you need to hop into each machine, and you need to update Linux or whatever operating system is running on it to have the configurations that. Hold on, let me up my microphone real quick. Sorry if y'all haven't been able to hear. Have you been able to hear anything to this point?
I've been hearing you, but you've been very quiet.
Okay, one second. Occasionally this happens.
I'm sorry, y'all. I should have said something.
Is that better?
Say a little more than that.
Is that better, y'all?
Tristan, what do you think? Still low.
Still low. Let's see. How about now? It's apparently not letting me go much louder than this for some reason.
Barry, I can hear you just fine. This is Daryl.
Well, that's good enough. I can plug in something. Is anyone else still having issues hearing me? Tristan, can you hear me now? All right. Sorry about that. I'll give him a second to come back. How about now? Can you hear me now?
I can hear you
All
fine, Barry.
Great. All right, moving on with it then. Okay, so infrastructure needs to be provisioned and configured. We already talked about what provisioning is, just saying I need this many of these different things. Configuring is hopping into the machines and actually making adjustments to the code, settings, installing applications, setting permissions, all that kind of stuff. The reason these two tools work together so well is that Terraform provisions and Ansible configures. Even the creators actually recommend using them together. If you want to get a really deep dive on using these two tools together, I would recommend you go and watch this presentation. It's nuts. They go completely off the deep end about how to use Ansible with basically every tool in the HashiCorp arsenal, which is a lot. I'm not going to cover all of them today, but they cover a lot of them. They cover the different use cases. They cover trade-offs where something that's in the Ansible arsenal might be better than something in the HashiCorp arsenal, and vice versa when they're overlapping tools. It's an excellent presentation. But for purposes of keeping this simple, Terraform is basically a tool that lets you describe the infrastructure that you want with code. So you can say, I need an EC2 instance that has this configuration, or I need to load this key pair. I need to create this VPC and open these ports inbound and these ports outbound, something along those lines. And you keep it in a simple structure with code. It's going to connect directly to the APIs of these different cloud providers. So each module they have is directly using the API of the provider itself. It's not using some third-party abstraction library. Like I know there's I think there's an Apache libcloud that gets used by a lot of providers and by a lot of tools that tries to abstract away all the different providers. Terraform doesn't do that. It connects straight to each one and uses them directly and has a module tailored exactly to the API that's available. It will also maintain a record of the current state of what you have told it to provision. If you've created something with Terraform, it knows the specific IDs of everything that you have created in each area of these different platforms. And if you say destroy everything, it will only destroy the things that it has created. If you try to modify something, it will modify what it knows about. It will not slurp down everything once you've connected it to your account just because you can see it. You can import you can import things that already exist into Terraform, but it is a one at a time process. There's not an easy way right now to pull it all in. I'm sure somebody's built a tool to pull everything in if you wanted to. But the short version of it is it knows how to create everything from scratch. It knows how to delete everything that it's created. It knows how to change from the current state that it knows about in its state file to the newest desired state. So if you've got 5 servers and you need to have 4 servers or 6 servers, and you just change the count, it knows that you've already got all these other ones, and it will just go and add or remove one if it needs to. It'll make the adjustment that it needs to. It also automatically figures out the order. So I'm going to show you some code samples later, and the code samples are kind of in an order to go with this presentation and help with readability. But it doesn't matter. It basically slurps in everything that you've provided and then it loads everything up and figures out what needs to come before what based on if you are referencing information from one resource that you've provisioned in another one. You can manually say this has to come before this. But for the most part, Terraform is going to figure it out on its own. It can be used to create a plan and then execute that plan. A lot of times when you're testing things out, you're just going to kind of do those in one big step. But it's possible to see exactly what's going to change and then put it through some type of internal review process if you wanted to and get approval. And then if you want, you can take the exact plan that it gave you and tell it to run this exact plan without building a new plan and then running it again from scratch. Great for change review processes and change control processes that might exist at a lot of companies. And it will also, once it knows the IDs of the different resources, if something has changed with the resources within the provider, if somebody's logged into the GUI, for example, and added tags to something or made some changes there, it will be able to pull in those changes to the local state file so that it can see what's different now. So, for example, you might want to remember this for later. You can create a security group on AWS. A security group on AWS is basically just an area where you, if you're not familiar with them, you specify which ports can come inbound, which ports can come outbound, and to and from which IP addresses or IP address ranges or CIDR ranges. So you could create a security group. You could only allow SSH access into that security group from your current IP address if you wanted to. You could load your SSH public key into AWS as a key pair that you could reuse later on. You might want to create a few EC2 instances and put them in that security group using that SSH key pair that you loaded up. Once those instances are created, you may wish to get the IP addresses of those, then go and create some DNS entries in, say, Cloudflare, something totally outside of AWS, or somewhere else where you might have a DNS. And once you've created new instances, nobody likes to go SSH into their instance and then get that big handshake warning. And a lot of people, because they hate that handshake warning so much, they do the insecure thing and they say, just disable the handshake warning. We're just going to not even check the handshakes. Well, if you want to, you can also go through and directly add the SSH fingerprints into those instances into the machine's known host file. And then when you destroy them, you can actually remove them out of the known host file. Or after doing all that, if you just need to make one small change to something and you reapply to your code, it would just make the one small change without disrupting anything else that was running there. Okay, that was a lot to say, but that is, it does a lot, and doing all that it's really, really simple. And it seems like it should be a lot more complicated than it is, but you can basically just walk through the GUIs on AWS or these different providers, look at the arguments that are available, compare them with their APIs and what's required and what's not in the modules, and you can figure out exactly what you need to insert. You can kind of use the GUIs as a guide to fill in your content the first time. But once you've built stuff with Terraform and you see how fast how quickly you can create and destroy things and iterate and get it right, it makes you never want to use the AWS or other provider GUIs ever again, because Terraform makes it so simple and fast to work with and iterate on and be able to repeat yourself and test it. And Terraform also comes with something called workspaces, where you can really, like if you're having a development and a staging and a pre-production and a production environment or multiple lab environments or something like that, you can create create a workspace for each one of those environments, and it will maintain an individual state file for each one. And you can use the environment name that you're in your various different arguments to name things and name security groups and VPCs or anything like that. So if you wanted to mirror your production, you can just say, okay, we're on the staging workspace, let's run it and create it for that. And you can even specify different arguments for different things. It's pretty slick. Ansible, it basically executes stuff over SSH. I mean, if you want to really boil it down, that's what Ansible does. It executes commands in parallel over a bunch of machines via SSH, and it does it, I hate this word, idempotently. Basically just means that once you run something once, it won't rerun a command if it can see that it's already been run. That's the entire point. So if you have a giant playbook that runs through 1,000 commands, and all of them except one thing that you changed in the middle has already been run, it will just run the one thing in the middle that needs to be run. That's pretty much it. And it sounds really simple. It can do a lot of advanced things, but one of the great things about it is because it's so simple, it's really easy to learn. I mean, if you've scripted something out in a shell script file or just on a command prompt, you can just copy that into a notepad, and line by line, you can go in and convert each line of what you've done into a task in Ansible that mirrors what that line of code did. But you can do it in a way that it will know not to repeat things, and you might be able to find even a smoother way to do it. And there are other factors in there too. There's something called handlers, and we're not going to really talk about that today. But when you need to restart a service, if a certain action happens, for example, you can do conditional things. So say you've made an update to a Postgres configuration file that needs to restart Postgres after it's happened, and maybe you've got 20 different tasks that do that. And if none of them run, you don't need to trigger the restart. But say all of them run, you don't need to restart Postgres 20 times either. And the handlers can figure this out. They basically roll it up and say, okay, once all this stuff is run, then once the last one is run, then and only then are we going to actually do the restart of the service with our handler tool. And there's lots of other little smart things that are in there, but for the most part, they're pretty straightforward. If you're comfortable working around on a command line in Linux, learning Ansible should take you a couple of hours tops. So together, Terraform will create and update your machines across all of the various cloud providers that are out there. It can also work with VMware. If you're in a local data center, it's got tools to work on your local data centers as well that might not be existing cloud providers. And then Ansible will connect to all these machines, configure them, update them, and run deploys to them, whatever you need to do. Anything you would normally be SSHing into these machines to do, you can do it with Ansible. Okay, so are there other tools that can do this stuff? Yes, of course, there are other tools that can do this stuff. As far as Ansible alternatives, you've got some well-known names like Chef and Puppet and CF Engine, Salt from SaltStack. You've got some simpler tools like SSH Batch that just lets you run a command on SSH across a bunch of different machines. You've got newer things like Rudder, and then there's always these shell scripts and raw SSH. Terraform alternatives. Ansible is actually a Terraform alternative. You can do a lot of the stuff that you can do in Terraform with Ansible. People don't like to, and I'll talk about that in a minute. There's other tools like Pulumi. I'm not sure the best way to pronounce that. You can use the APIs directly with your own scripts, and you can do provider-specific tools like an AWS CloudFormation. With all that there, why exactly are these two so popular? First, they're both very good at their specific task. They've gotten popular. They've got big ecosystems around them with plugins and tools that can make stuff even faster. They're really, really simple. You don't need a special tool. You don't need a special GUI. You don't even need a fancy IDE with plugins. You just need to open a text editor, and you can work on this stuff, and you can find your way around without a whole lot of headaches. It's pretty fantastic that way. You can do small things and you can do big things. There's a lot of tools out there, like, say you wanted to come in and use something like Puppet, for example. Puppet has to have an agent installed on each machine that it's running on, and that agent has to know how to connect to a master node that's keeping all of your configurations of what it's doing. And then those have to be set up and pulled down. And if you're going to use these tools, if you decide you really, really want to use Puppet, then every place that you have to go, you have to convince them to install this agent on the machine that you're working with. You have to convince them to set up the master node. You've got to maintain it. You've got to do all the updates. You've got to start pushing everything through this. If you want to use Ansible and you have SSH access, you can just start writing little Ansible playbooks for any little task that you're doing, whether anybody approves of it or not, because all you're doing is running stuff over SSH just like you have access to do anyway. The level which you can take it to will certainly depend on the organization, but if you can be trusted to do SSH, you can use Ansible. And you can do much more advanced stuff with them as well if you need to. They're open source, which I don't have to tell y'all. And it's language independent. And I find this is pretty important. Ansible is basically just a bunch of YAML files. And I know some people don't like YAML, but it's pretty straightforward for what they're doing here. And I find it to be a pretty good use case. The HashiCorp or Terraform uses HCL, which is HashiCorp configuration language. And it's just a simple JSON-like language. A lot of these tools tried to fight turf wars early on. Like Chef and Puppet are both written in Ruby. For Chef, you were actually using Ruby to work with. There's a lot of people who would not touch Chef with a 10-foot pole, specifically because it was written in Ruby. It didn't matter how good of a tool it was. Ansible is written in Python, but you don't run a lick of Python to do it. You don't need to know anything about Python to do it. Python's probably in one of my bottom 10 least favorite languages to deal with, just because at the point that I started learning it, I knew a lot of other languages that I liked a lot better, and it was just kind of painful for me to walk through. I know there's a lot of people that love Python, and there are tools out there that will let you write native Python. There's tools like Pulumi's big push is that it's in your native language. CF Engine's written in Perl, but getting rid of that question, do I need to learn this entire programming language to use this tool, helps a lot with getting people on with it. You don't have to, because people get really defensive about their languages. I mean, I don't have to tell y'all. Y'all know when people really get into a particular programming language, if you mention something that another language can do, they'll start telling you exactly why their language can do that too. It doesn't matter what the trade-offs are. And people just naturally get defensive about the things that they've invested their time in using. And if you've invested any time in just writing shell code, you can do Ansible already. It's really straightforward. There's no turf wars here, and that's one of the things that's I think really contributed to the popularity of these two tools. But they're not without their complaints. So Ansible, biggest complaint with Ansible is speed. There are other stacks that are out there that specifically all they do is market the speed and performance of these tools. There's reasons that Ansible has some speed hangups. First off, it's doing an SSH handshake to connect to each machine. You can streamline that. There are configurations you can do to fix it. The idempotent check steps, because it's not maintaining a state file of everything that's already running on the machine, it has to check each step. It does its fact gathering before each step to see where things stand. That's necessary for, it's one of the benefits that you get with Ansible. It's a feature, not a bug. but it can cause things to take a little bit longer depending on if there's a really slow check step for some reason. Operations are sequential. You can set up certain things to be async, but by default it is sequential. So you can run in parallel on a bunch of machines to speed things up, but it is a sequential process, and it is push oriented. There's a lot of tweaks and things you can do in terms of pipelining and control path. You can set apt cache validation time or cache valid time, so that whenever you're installing a package, before you do an apt install or a yum install or df install, before you do any of those things, you're going to do an update to make sure you have the latest versions of things before you install a package. And you can set the cache valid time so that every time you do that throughout your process here, it's not going to refresh every single time it sees a step that calls for installing something from apt. And that can speed things up significantly. There are options for async tasks. Ansible does have a pull mode. So if you've got a fleet of 1,000 machines, you can have them all pull down the instructions just like the agent-based approach. But you lose some of the perks of Ansible in terms of control. But if speed's all you care about, you can do that. There's also an option called callbacks enabled. It's now built into Ansible 2.0, which will let you profile each task as it runs. So at the end of your entire playbook run, you can see exactly how long each step of that playbook took to run. So as you're going through and trying to optimize things, you can really see where your bottlenecks are. Terraform, biggest problem is that you're not going to get the most bleeding edge features right as they come out. You're working with you're working with a module written on top of the API, and when AWS launches a new feature, there might not be a Terraform module for that feature yet. There's going to be some lag time for it. There are workarounds. You can make your own PR to an existing provider. You can write a custom provider just to handle the feature. The provider's written in Go if you decide you need to do any of that. You can write something to hook up to the API directly yourself if you wanted to, without worrying about it, and just kind of manage it manually until you can roll it in. But if you're hanging on the ability to use something the second that it comes out, you're going to have a lot of waiting periods built in with Terraform. So that's something you need to know. But again, my favorite thing about this is these are tools that you can learn and you can always use without asking anyone's permission to use them. If you have access to SSH, you can use Ansible. If you have an API key for a cloud service, you can use Terraform to do anything that you can do as your user. It's pretty fantastic that way. If your whole team and whole company decides they want to use these tools, that's awesome. But you don't have to wait for the process that happens. If any of you have been in large companies, and I know you have, you know the hellish process that comes along with the meetings and people fighting over tools and people recommending which tools are going to be used, and then people taking weeks on end to do research into different things and doing a pro-cons analysis and leadership discussions and budgeting and training and all of the stuff that goes on to decide which tool everyone has to use. You can just start. It's a wonderful thing. Anyway, basic examples. So Terraform. Terraform uses the HCL HashiCorp configuration language. Can you see my mouse pointer here? I think you probably can. A Terraform file basically just looks like this.
I don't see it, Barry. I think there's a way to have a ghost. Oh, there, I see it now.
Okay. All right. So I guess I just had to click into it. So this is basically all it is. It's just this kind of bracketed language where you define what thing that you're working with. You will get a module name referencing whatever that thing is, and sometimes there might be additional names for it. So here we're configuring AWS as a provider, and we're setting the default region to US East. You can put your secret keys and stuff in here if you want to. You can also put them in the standard AWS environment variables. You can use a .env.rc file with something like dir.env to do it in the directory that you're working in. I find that pretty straightforward. Then after that, you're going to basically be setting up a bunch of different resources. And so the resources are just, you'll say resource, you will name the module, in this case, AWS key pair. and then you're going to give it a name for whatever this particular iteration of this resource is. So in this case, this is the Brightball AWS key pair. So I'm just going to give it this key name, and then I'm going to give it the public key file. Now, everything by default just uses, a string here, but you can just tell it to load anything from a file, just as you would expect. It's pretty straightforward. That you basically, once you see this, you're basically just doing that over and over and over for each resource that you want. I mean, there's loops and iteration and stuff when you've got a set of them, but for the most part, you're looking at as complex as Terraform really gets. I told you it was simple. And so all of the TF files in your directory, you can split things up into as many things as you want. If you want to split things up into different services or separate them out in ways that make a lot more sense to you, it's just going to look for every .tf file that it sees in the directory, and it's going to slurp them all up together and combine them in the end, because it figures out the order of dependency among these things. So you can separate things out to your heart's content, but you don't have to. There's also a structure of modules. We're not going to talk about that here, but it lets you define some cleaner separation if you want to define a module that has specific inputs and then specific output variables. So just as you get into more deeply learning Terraform, that's something that you will come across. Ansible, like I said, it's just YAML. That's it, just YAML. So here's just a sample Ansible playbook where it just goes from top to bottom. Ansible runs in order, so sequence matters. And so first, I'm going to start out with running some stuff on localhost that I've defined in an inventory file, an inventory of hosts. Then I'm going to set pre-task, and this is just a list of task files that I've included. And then I've got my actual tasks. Pre-tasks matter because there's all these third-party packages called roles, and you can also define your own roles for reusable things. But when you use a role gets executed before tasks do. So if you need to do any machine setup stuff, you need to put them in pre-tasks if you need them to run before roles. So that's why that's there. Become will, if you say yes or true, it will basically run that task, everything in that task file as root. Or you can specify a specific user to become to run that set of tasks on the machine that you're on. Then next, we're going to see the next set of machines here. We're going to say on the runners machines. So this is going to be all the machines that are in my runners group. And runners, it's just basically something I created for sake of experimenting in this presentation. Just call it a code runner machine, something I'm going to fire up, install Ruby on it, and then be able to connect to a database on the network to run some queries or something like that, and then tear it down when I'm done. But this will run it on everything in the runners host group, and it will go through. It'll go install Ruby 3 and compile it from source and everything after it's created some users and installed some dependencies. And I can continue the sequence if I need to hop back and forth between different machines or different sets of hosts while I do run one set of tasks on one, then some more on another, and then go back to the other. You can even get more fun with this stuff if you need to copy stuff from one machine to another. There's ways to do that. You can tell it to copy. I've used it before to export data on one machine, zip it up, pull it down using a jump server as an intermediary, and then pushing it back up to the new server that it needed to go to, and then execute the command on the other server to run the import on those other machines. You can do a lot of stuff on here. One of the things that people take for granted about Ansible and shell scripting in general is how much of a pain it can be to switch to specific users over SSH and then run commands while you're hopping back and forth between them. Ansible makes it stupidly simple. And the first time that you try to just run stuff over SSH and switch users and see what a pain it is to jump back and forth between different users for different things you're doing, you will appreciate that. If you had no other reason to use Ansible, the simplicity of that is probably a good reason to use it. As far as what these tasks files look like, these task YAMLs look like, this is basically just a sample. And what you have for each task is you name the task, literally just anything you want as a description for you. You name the module that you're using. And so in this case, I'm using the app module specifically. There is a package module that abstracts all the different package managers away. But you can also invoke each one individually. There's one for Yum, there's one for DNF, and they've got them for all the different distributions, but the package option will abstract them away. If you need to do specific types of things on a specific version of Linux, for example, you can also put if statements in that will skip an entire step unless it matches the conditions in the clause. Like, if this is Red Hat, do this or not. And so sometimes if you pull down a roll file from Ansible Galaxy that's made to run on multiple versions of Linux, you'll end up seeing skip steps when it runs, and that's one of the reasons why. In this case, we're using the simple little Jinja templating language here. This is just bracket variable name, and item is standard if you're looping through things. So what this is going to do is just going to loop through and install each of these one by one after updating the cache one time to the latest state. And one of these files can have as many tasks as you want. You can just keep listing task after task after task. So you could have an entire task file that says, all right, I want to download, compile, and install all this stuff. And you can tell it to pull something down from Git, unpack it, make it, build it, copy stuff to where it needs to go, change permissions. And at the top level, you would just include that YAML file. So how do we use them together? This is where the fun begins. So there's a lot of different things you can do. You can have Ansible run Terraform I'm going to cover these in detail in a little bit. You can have Terraform run your Ansible code. You can run both of them independently, trying to let them share information between each other. Or you can have Ansible run Terraform to run Ansible. If you go back and watch that presentation that I mentioned earlier about HashiCorp with Ansible, they go through a kind of nutso configuration where you're using a tool called Packer to build a portable machine image. It's portable across different providers. So you use Packer to use Ansible to build a machine image that you then deploy multiple instances of across different cloud providers with Terraform that's getting its secrets from the HashiCorp vault somewhere that has all of the encrypted secret data. And then you're providing a vagrant image to your developers to work with locally that completely matches the image that you just put out. There's all sorts of really nutty stuff you can do, and depending on your environment, more complexity might make more sense to smooth things out. But the basis for communicating between these tools is variables. So with Ansible, you've got the ability to store variables in a nested YAML structure. So when you define like a group of servers, you can set variables up in this nested YAML. You can set an all, where variables are available to everything across your entire Ansible run. You can set things in a named set specific to a group of servers. So these variables only available to these certain groups of servers. And you can also do host specific. So if there's specific variables for specific machines, you can set that up as well. You store lists of these hosts and groups and inventory files with the IP addresses and host names and group names of what you're connecting to. And in any step, any task along the way that has output, you can also register the output of a task so that you can reference it in a follow-up task. But by default, it's not available unless you tell it that you need to register it. With Terraform, you can create variables with defaults. You can create variables just as you would assume. They're typed variables. By default, they're just strings, but you can specify a type of number or a list or a list of numbers and maps and everything. You can create a TF vars file that is just basically a list of variables as you would expect. So you can define your variables within, and then you can have a vars file that gets included to overwrite whatever defaults you had set in there. On any given step, you can set specific output variables. You can, at the end, you can tell it, I need this information from these different things, and I need these to be output at the very end. And we can reference these different parts throughout the other side here. But the other basis is of course just writing the files themselves. Both Ansible and Terraform have templating engines, and so you can use Ansible's templating engine to write a TF vars file for Terraform. You can use Terraform to write an inventory file for Ansible, or a variable file for Ansible if you wanted to. There's just so many options to work with. Take a drink for a second. Okay. So, going to give you a quick high level of each one of these different options, and then we'll talk about the one that I'm going to demo for you in a minute. Okay, so Ansible running Terraform. The thought process here is that you're going to use the YAML nested tree structure of variables to have Ansible run Terraform. You're going to have Ansible take the variables that are stored centrally within Ansible to generate TF vars files for Terraform every time you're going to run it, so that you can pass whatever the variables were in Ansible into Terraform before it runs. There is a Terraform module for Ansible that will let you run Terraform, and it gives you some great options. Then you can capture everything that came from that Terraform run. After that, the variables that you can put in Terraform output can be referenced directly by name from the output of that Terraform module. So if there's specific things that you know Terraform is going to need, like a list of IP addresses or something like that, you can put them in there. And you can register them so that Ansible can see them at future steps. And the other thing is with that Terraform state file, even if you run Terraform and there's no changes whatsoever, you're still going to get those output variables because it's just going to pull them out of the state file and send them back to you. So whether there's changes or not, you're going to get the same output every time you run it. There is a lot of complexity to the setup. In terms of downsides here, it's a little bit annoying to know that you can't get the information from Terraform without actually triggering that Terraform module run every single time. But it's one of the trade-offs you're getting with this. There's the Terraform running Ansible option. So this is also a very popular one. So this is where you keep all the variables in Terraform. And then instead of running Ansible, where Ansible knows about all of the different hosts and all the different variables like it would normally know, what you do is, when you tell Terraform to provision 20 machines, you can set up something called a provisioner, which is just some code that runs after the machine is provisioned by Terraform. And you can tell it to say, okay, now go run this Ansible playbook, and you can pass it the IP address of that specific machine. And so Terraform, if you created 20 instances, you would have 20 instances of Ansible running playbooks for different machines that were triggered locally by this, and Terraform would control it. This is a great option. It's a very popular option. You can also use Terraform's remote exec option, and this is another popular one, where it will happen, where you can have it just run a simple shell script to install Ansible on that machine, and then download your playbook, and you can just have it run Ansible on the machine itself. It can just run the playbook on the machine itself to self-configure. These are both pretty popular options. You'll find a lot of blog posts out there that do it. So running a bunch of local execs, depending on how many machines you have, that could stress the machine that's running it. You could end up with potential lock file issues and whatnot. If you run Ansible on a fleet of machines, there are concurrency controls within Ansible to do that, and in a very controlled manner. And there's a lot of options for how you can control that. So you lose that control from Ansible if you do it that way. The remote exec approach scales well. The downside is that you have to have the entire Ansible playbook sitting right there on that machine to pull it down. So having Ansible run Terraform and then having Terraform run Ansible, it's just basically a multi-step process. You're getting a lot of stuff here. It just gets more complex, but people get weird when you start digging into to the different options that are in here. Simplest approach, you can just keep them separate. You can go and you can run your Terraform build, and then you can hop over to your other directory, and then you can run your Ansible build. And just using a simple Terraform template, you can generate the Ansible inventory file, so that before you run your Ansible playbook, all of the inventory of your machines and their IP addresses is there and ready for you. The downside is this is the simple thing that's not cool to blog about or write about, then it might make you feel old and practical. Some of us like that. So the crazy stuff, I'm not really going to get into this. You can go look at the blog post and watch the video if you really want to get into it, but it gets nuts. There's also paid tools like Terraform Cloud and Ansible Tower that can help you handle team orchestration and all that other stuff. One thing to know is that with the Terraform state file, if any of you are wondering about this, is if say you're running this on your local laptop and you're dealing with a team of people, the state file would be different on your machine and someone else's machine. There's something called a Terraform backend where you can tell it to use a backend that has nothing to do with the rest of your infrastructure. So say you're on Google Cloud, you can tell it to use an S3 bucket for the backend. And it will basically if you create a backend for it, it'll move the state file from your local machine to S3, and then it will take advantage of S3's file locking capability so that if you run it, it will lock the file. Even if there's 20 of you that might be running Terraform related stuff, the backend will handle locking the file for you. And if you, of course, were to use something like a CI system, like a GitLab or Jenkins or something like that, to handle running these different playbooks for you, which is, of course, very common, that would also kind of take care of it because you'd be doing things in order there. Okay, so I didn't get any questions.
I do have a question. Yeah. If the file is locked in S3, does that mean that the second person has to wait, or it just airs out for them?
If the file is locked, you wouldn't be able to do anything. It would air out. So they would just have to wait until they could get access to the file. I mean, I think I'm answering what you asked. You were really correct.
What I'm asking is does this form
You're really, really garbled. You might want to type the question. I think Derek is answering it right now. All right, so I'm going to stop sharing real quick and exit my presentation. I'm going to close this presentation out real quick, and I'm going to reshare VS Code instance over here so we can look at some real code. I know y'all probably have stuff you want to get to tonight, so we will cover that in a second. So let me try sharing this real fast. All right, can y'all see that all right?
Yes.
Sweet, okay. Okay, so I told you I was just talking about a simple runner instance here. I'm not getting into anything too crazy. But this is our little top level directory. This is apparently a common pattern if you're going to do something, and if you're going to use both these tools together, is just to have a directory naming whatever you're working with, have a Terraform directory, have an Ansible directory, put your environment variables in there. I'm not going to click on that so you can't see my private keys. And if you want to use tool versions and stuff for that, or your git ignore files, whatever else. Straightforward project structure. So this is the main TF file. The general structure that you would have with Terraform is always going to want to have a main.tf file to start with. But like I said, all of these other files are just going to be combined when it first runs. So we're configuring our provider up here at the top. There's a plugin for VS Code that'll give you these nice little mouse overs and stuff. So you can jump over to documentation and whatnot. And it's pretty straightforward. Providers are all documented and listed on the Terraform registry. But I'm setting my default region here. The access keys have already been set in my environment variables. Creating a resource here using the AWS key pair module, adding my public key up. Then I'm going to set another variable here. So this is when I go to create my security group, I'm going to create a list of numbers for the ingress for my security group. So we're going to have SSH port and then a future SSH port that I may switch to at some point. You can define data sources, and there's a lot of different options for this. So I'm going to define a data source right here with the HTTP module, and I'm going to reference it by the my current IP name. So all this is going to do is it's going to go and use the icanhasip.com, which just you hit the URL and it shows you your IP in the body of an HTML response. So it's just a helpful way from wherever you are to find out what your IP is. And so when I need to get my IP, I'm going to get it from there. And we're going to come down and look at the AWS security group here. So I'm creating a resource using the AWS security group module. I'm just going to call it my main security group here. You can give it names. And here you basically just define your egress and your ingress. And so I'm going to just, normally you would just define this if you just had one thing you wanted to define. You would define your CIDR blocks, add a description, ports, protocols, setting them to 0 just allows everything. You do from port and to port, so that lets you define a range. So if you wanted to do all the ports from 80 to 100, you would just say 80 from to 100. And you can define security groups there as well. For dynamic, this is just going to loop through. And so what this is going to do is we're going to do a for each on our ingress variable that we created up here. And admittedly, the looping structure is a little wonky looking, but it's pretty straightforward. And so we're just going to iterate on that, and we're going to call the value that we're iterating on the port. We're doing the for each here. And so we're just going to go through and just going to create one of these for port 22, and it's going to create another one for port 222. And then you can see over here that we are referencing our data from our HTTP module using the my current IP, and we're getting the body of that. We're running our little chomp on here to chomp it down, and we're putting that in an IP address in the CIDR block, and we're giving the /32. So it's just that specific IP. Now we're going to get down to our actual EC2 instance. So we're going to have a resource of an AWS instance, just a EC2 instance. We're going to name this type as a runner type, so we'll reference it later. You put in the specific AMI image that you want to use. And so if you want to use your own, if you want to use one of the pre-built ones, I've kind of given a note here of what this is. It's a 1220 US East. Quick gotcha is that the AMIs are different depending on the region that you're in case you didn't know that, now you do. And they come with the default user. So in this case, it's an Ubuntu instance and the default user is Ubuntu. Count says I'm going to create 3 of these instances. I'm going to put it on a T2 micro. And now we're going to go back and look at our AWS security group main and ID, and we're going to include it in that. We're also going to load in the key that I loaded in earlier. I'm going to reference that AWS key that I created earlier here. For tags, you can create any tags you want, of course. The name tag is a reserved one. And so I'm going to just give it a short host name and the name tag so that I can reference it on my list of resources. And if you have a count on here, you can do count.index, and so you can reference each one that you're going through as it's building multiple instances. So this is going to go from 0, 1, and 2. And so we're going to have runner 0, runner 1, and runner 2. Then I'm going to give it a full host name on my little ops subdomain here. Giving it a tag name of a type just because I want to, and I'm putting the user in there too, just for my own memory's sake. This is all just for examples, by the way. So within this this bracketed bubble of the resource, I've got provisioners, and you can create multiple provisioners. So if you want to connect over SSH to an instance, one of the things that you need to do is you need to make sure that SSH is available. And so if you know you're going to be connecting from your local machine over SSH doing something else, go ahead and just do a simple dumb thing over remote exec. Connect to it, echo, hi, I'm here if you need to. But doing that, the remote exec provisioner makes it wait until SSH is available to go and run whatever it's going to do. And so do that first, and you'll make sure of that. In this case, I'm just going on and I'm setting the host name for the machine. And I'm dumping that host name into a little default host name file in the home directory of the user. And this is just an array of commands to run once you get there. It's just defining the connection to use, user, and the IP address that you're connecting to. Then I'm running another provisioner, local exec, and for some reason, I don't know why, but when you do remote exec, you can create an array of a list of commands, one after the other. Local exec, you can do one command at a time. It's weird. So what I'm doing here, now if you want to get into it, if you really want to get into it, there are tools in here and modules in here to get specific SSH keys and put them straight into your known host file if you want to. I am just calling out to the command line with SSH key scan for the IP address and loading it into known host. Just a simple shortcut to do that. And then after that, I'm doing it again. Oh, and then we've got a provisioner here for when destroy. So this will only run if I'm destroying everything, and this will go back and remove those entries from known hosts. If you've noticed here, there's this TSP-NF at the beginning here. This is something that I just kind of discovered as I was going through here and I was trying to solve a problem. I'm not going to talk about it too in depth, but there's a great package available on Linux that I never knew existed called Task Spooler. And Task Spooler is basically just a simple command line queue. It's awesome. You can just pretty much prefix any command line command, and it will add it to a queue, and they will run one right after another. You can tell some of them to run concurrently if you want to. It tracks the exit status. It automatically generates a log file to send the output to, or you can pass these commands of -nf, and it will log the output to wherever you tell it to, in this case, known hosts, and it will just sit here at the command and wait until it is run. So it will hold whatever process is running right there. So this came in because I was using keyscan to add to the known host file, but I was doing it for 3 instances. And so it was running this command 3 times on my local machine, and it was getting a conflict because they were all trying to write the host file at the same time. But by using Task Spooler on my local machine, these run one after the other once they finish, and the race condition is eliminated. This is awesome. I just discovered it last week. I'm going to use it all the time. You're welcome. And Jonathan's very excited about that, so that's awesome. And so that is the basics for that. I'm not going to get too far into this. I'm also going to be setting up Cloudflare. I'm going to go on here. I'm going to basically just create a, it's going to go through for all of the runners that we created. We're going to get the host names and IP addresses, and we're going to create entries in Cloudflare for each one of them when it's done. And I've got provisioners in here because you can put provisioners on any resource that you want. And those provisioners are doing the same thing because you can also use SSH keygen with host names if you want to. That doesn't really matter for Ansible because Ansible is just going to use the IP addresses that it finds, but just so you know. And here we're doing the same. Actually, this was just removing it from there. This is adding it to it. And this one, because the DNS load time is not always instantaneous, especially if you've done this over and over and over. The first time with Cloudflare, the record is pretty instantaneous. Subsequent times, not so much. So it's nice to just add a little failure condition here because if it fails, you'll get a big failure in the middle of your Terraform stuff. And so just putting a little, because since this isn't critical, you can just not really care. Inventory out. So what we were talking about using a template file, this is something that's going to go through, and after we've created our instances, it's going to pass the AWS instance runner with all of the information that the runner has available after they've been created. And it's going to pass them into this template file that it's going to write. It's going to set the file permission, and it's going to go and move it to my Ansible hosts file so that I will generate my Ansible inventory when it's done. The template is pretty straightforward. It's basically I've got my local and my Ansible controller local definition, so just to define my little local host. And runners, I'm defining a runners group here. This just uses the INI file format. And it's going to run through it's going to run through the list of runners here. I'm going to use the name that I set in the tag list. I'm going to pass Ansible host just so that it knows the IP address. I'm going to pass the user so that it knows to use the Ubuntu user. And then I'm also going to give it the machine ID that Amazon gives me when it's done. And it's just going to print those on a line-by-line basis. Pretty straightforward. So for any type of machine you have or type of group, you can make this work however you want to, but it's really straightforward to generate this file. And that is pretty much Terraform. So now we've got all that, I'm going to pull this terminal up over here. And the first time that you run Terraform init, and or whenever you add a new module, you also run Terraform init because it'll download the module so that it can find the AWS module and the Cloudflare module and the HTTP module and all that. It will pull in the modules that you need to be able to run these things. Then run Terraform apply. What this is going to do is it's going to go through, it's going to connect, and it's going to generate our plan of action. It's going to ask me what we want to do. So I'm not going to run through this line by line, but you're going to get the idea pretty quickly. It's going to tell you everything that we're doing. Okay, so this is where it started. So you'll see the abbreviations here for this, but this is what's going to happen. You're going to create AWS instances. This is going to be runner 0. Instance type. A lot of these things say known after apply. It's going to use that key. Here's our tags that we're setting. A lot of the stuff is not going to know, but you've got lots of values and variables and everything that you can configure in here to your heart's desire. If you want to add block storage to it or any of that fun stuff, different network interfaces, go nuts. And then you're going to see the same thing for the other instances that we were creating here. There's the key pair that we're loading up, my little public key there. Then we've got our security group. So here's the egress, this simple allow everything out. And we've got our port 2322 from my current IP address right there. And then port 22 right there. And I found one of the handiest things about this when I really wasn't even thinking about it was that if I'm creating a take my laptop into the office and I just run this again, it just runs through real quick and just updates my current IP address to my office IP address. And then I go back home and I just run the command real quick and boom, all of a sudden it updates just because that data changed based on where I was. I was going to demonstrate that with a VPN connection, but it might kick me off the call, so I'm not going to. Okay, so we've got our Cloudflare records, our DNS records, and so we'll have the entry and we'll have runner-2 ops, a record type, values and everything are going to be known after we've applied because they're getting built later. And then it's going to go and create that Ansible inventory file and inventory host. So we're going to create yes. It's going to do this real quick for us. You can see just exactly how quick it does this too. Didn't want to run a plan first. First, apply will give you a plan that you can use. You can do plan and apply separately if you want to, but I did not choose to do that for this example.
Yeah, I must have something weird in my config. I've never seen it ask me before it doesn't apply. Maybe I'm not knowing.
That's a setting.
Yeah.
You can also pass that at the command line. So now it's waiting to connect to the remote hosts over SSH. Now we're adding our key scans in to load up our known host files. It's creating all the DNS records in Cloudflare, and boom. And so this is where you would see, looks like it worked. All right. So now I'm just going to SSH in as I created myself. Yeah, what's his name from Dodgeball? Did not get the DNS fingerprint. Sorry. That was anticlimactic. It'll be fine over the IP address, I promise. All right. Oh, for that last step where you didn't have to have it based on that, but it should. Anyway, all right, flipping back over to our Ansible code now. So Ansible, we'll see that we created this this nifty little host file. So we've got our runners with our hosts, our Ansible user information, straightforward Ansible inventory file right here. In your configuration, I've got some things in here to do control path and speed ups for profiling and whatnot. You can see a lot of people like to disable host key checking, but I've left it there. There's little tweaks that you can find in terms of how to speed things up. There's lots of blog posts about how to speed things up for you there. But our big playbook here is the runner playbook. I'm not actually going to run the local thing. This provisioner is what would actually run Ansible if I was, or run Terraform if I was running it from there. I'm going to show it to you. It's just the Terraform module where you would give it your path to Terraform. And then I'm registering the output variables from Terraform, but we're not doing that today. Creating users, you can go through, create some admin users and stuff, yada yada. Dependencies. This is a way to speed up your dependencies. So in the example I showed you in the presentation, we were doing it with a loop where it was going through each one at a time. But as you know, you can use apt and install a list of dependencies all at once in a single command. You can do that here as well. And so what we've done is in the runners group variable, I've just set up my dependencies as a variable in the YAML file over here. And now we're using just a simple string join to join these dependencies in here. And this will let it run, and we've got the cache valid time there. TSP, this is just for fun. Locally, we were installing Task Spooler if I needed to. You can set up any files that you needed to. If you're using like a default gems file or something like that, you can do that, pass it along to the machine. But my runner instance is just here. So I'm configuring unattended upgrades on the machine for automatic security patches because I like that kind of thing. I'm just installing Ruby 3 using this Gearling guy role over here. He's just pulling it from that location, installing my dependencies right here on the runner machine, creating the users and admin users and adding them to the sudoers file. And other thing I want to show you is just, if you ever want to test things and you're just wanting to run one task over and over, it's easy enough to just create like a task test. Because whenever you execute a playbook, you pass it which YAML file you want it to run. So you can just create a one-off just to test one piece of what you're working on without running the entire giant playbook every time. You can just test task after task and then put the include that you just finished working on back into your overall bigger task set if you need to. And let's see. All right, so I'm going to run this and let you see it run. I'm not going to make you sit here and wait for it to finish. I'll answer questions while it's running, just because the part about compiling Ruby 3 and installing Ruby 3, for whatever reason, it takes a long time to install Ruby 3. So I'm going to let it run, and then here we go. So we're just going to do Ansible playbook runner go. And this little line right here is the profile we're running. It's adding timestamps along each phase. And so we have our facts. Now it's going to start the install base packages. And these are all running in parallel on each machine. And so this is the decoupled approach that we talked about, where we just run Terraform and we have it build an inventory file, and then we can hop over to Ansible and use Ansible just as we normally would. If we have variables that we need to share between both Ansible and Terraform, it's simple enough to just put those in higher level environment variables if we want to. But if you were getting really, really fancy, you would probably end up putting them in some type of shared vault type structure, potentially the HashiCorp vault or something like that, that both things have a way of speaking to and getting information from. But if anybody has any questions while this stuff is running, okay, you can see the packages are being installed now. And so instead of seeing okay, like we saw up here, we see change. So okay is what you see when nothing needed to change. changed means that it's actually running whatever the command was at this point. So it's going and installing those packages. Now it's doing these safe upgrades to the base packages right after that. I have not. I actually don't know what SSM even is. What is SSM?
It's a configuration management thing for AWS.
Okay. I'm not familiar with it. I'll have to look at it. What does it do?
It does a lot of different things, but you can. There is some overlap with Ansible. That it also has its own, parameter store and has a lot of different components to it.
Gotcha. I have not tried running that. More than likely, I probably wouldn't, just because one of the things that attracted me to Ansible in the first place was portability. I tend to avoid using the provider-specific tools. Can you use it with? I mean, can you run things on other providers with it as well, or is it just for AWS?
Derek may know more than I do. I know they make an agent that you can deploy, an SSM agent that you could go and, in theory, maybe deploy on non-AWS boxes, but I've never even thought of doing that. But there is technically an agent out there. I don't know.
Okay. Yeah, that's. I mean, there's the agent approach seems to be what a lot of the different providers like to do. So that would kind of be in the Salt or Puppet space right there.
Yeah.
So it does make sense.
Right.
Is this working now?
Yeah, it's doing the updates to the packages, and because I was telling it to do the package upgrades.
Yeah. Hey, this is Derek. Sorry, but my microphone was on the wrong device. Yeah.
You're good.
I was looking into it because it seemed kind of cool, and I figured you were using AWS. I wasn't sure if you had a chance to check it out, but yeah, apparently it can do like automatic creation of like the inventories and pull things based on tags and such with AWS. So it's something that's on my eventually check it out. So I was hoping maybe I could shortcut some things if you had, but
no, unfortunately not. One of the things that got me into Ansible in the first place was about 2 jobs ago. I was working on a Ruby team that was in AWS, and I was automating a lot of their infrastructure and their deployment process and their automatic scaling and whatnot. And I was doing it with just using the AWS API directly with Ruby code, and I was using the Perl library SSH batch, which just gives you the ability to run SSH commands, run commands over SSH in parallel across multiple different named groups of machines. And I basically just combined raw Ruby with that to get on the machines and run different commands and handle the deployments. And it worked really well, believe it or not, as patchy as it all sounds. But what frustrated me was that the next job that I went to was entirely Google Cloud based, and none of that was particularly portable, and no one else really wanted to sit down and read my Ruby code, as no matter how many Spaceballs jokes I put in it, and there were a lot. But so I was trying to find something that wasn't, and it was also a Python company that I was at the next time, and so finding something that didn't depend on a specific language and that was portable across providers, because you never know which cloud provider your company is going to be using where you are. You could end up somewhere with Azure or something like that. It made me realize that I wanted to invest my time in learning tools that I could take with me wherever I was.
To your point, Barry, the jaded pessimist in me would answer your earlier question of AWS SSM is a way to give Amazon more money, whereas you could just do Ansible. But yeah,
I like that. Yeah. It's also a way for people at enterprise companies that have gone through the entire procurement process and have approved all things AWS for their procurement sake to say, well, AWS has that now and we're approved to use AWS. So
yeah, it might be one of those ways if you can't get Tower squeaked in, instead of using Ansible Tower, you could use SSM.
Yeah.
Exactly. So this Ruby build step is going to take a while. Y'all are welcome to hang around to watch this if you want, but the presentation is essentially over at this point. So if y'all want to ask any other questions, feel free. The only thing that will be left to be shown at the end of this is once everything is done here, the profiler at the very end will show you a summary of all your completed steps, and then it will show you your steps ordered from slowest to fastest, and how much time each step took along the way. And that's pretty much it. And you're welcome to hang around for that if you want to.
I actually do have one more question, but first off, speaking of Ansible Tower, we shouldn't dissuade the use of that because we have a new Red Hat employee in our midst. So anyway, I had a question about your one of your Terraform files. I think it was the cloud for DNS.tf.
Yeah.
I had actually a philosophical question about something you were doing there. One of your resources, you were doing a for each in there, and
that was in the main. That was a security.
Okay, I'm sorry. Yeah. So you were doing a for each in a way that I've never seen it done before. Yeah. So you were doing a dynamic block on there based on each port. I was curious why you wouldn't just like in your actual AWS security group main there, why wouldn't you just say for each, on ingress.port or whatever, for each var.ingress.port or something like that. I'm curious, what does the dynamic give you?
I mean, all dynamic does is it just basically creates the variable in a list and lets you loop through it like that. To more specific and detailed questions, unfortunately, I can't tell you. This is an example that I got in one of the tutorials that I went through on Udemy.
Got it.
And it was just their example of showing you looping. And apparently, Terraform, for the most part, dissuades using this structure. But the presenter and author's example said that he thought this was about the only situation where it made sense.
Interesting. Yeah, I know in some of the recent versions they've expanded and changed their for each capabilities, and so I didn't know. But yeah, I've never seen that dynamic used like that. I'd have to research that. It's interesting.
Yeah, I can, if you want, I'll flip back up real quick and show you what it looked like in the plan while this is all running. So on the plan, we had security. So it came out looking like that. So we ended up with a list of each CIDR block as it just kind of looped through and created.
Cool. Yeah, that's interesting. Thank you.
No problem. Anything else? You really don't have to wait for this thing to be done. If anybody had anything they wanted to close out with for the group meeting, feel free.
Well, Barry, we appreciate you showing us this. This is pretty cool. Am I still unhearable? Do I make any sense?
You're better now.
Yeah.
Okay. But yeah, so thanks so much for showing us this. This is I've been wanting to learn Terraform, and I've just recently learned Ansible myself. So this has been very enlightening. I appreciate this. If there's no other questions anyone has, let me change gears and see if anyone would be willing to give a talk next month about anything else.